All right, I think we'll get started. So thank you everyone for joining our webinar today, StreamNative webinar. Today we have a special guest, two of them, Andrew Bruce from Gigaom and the CEO and co-founder of StreamNative, Sijie Guo. So before we get started, I want to give you a couple of housekeeping items. So today's session will be recorded and then we will send you the recording to the email that you registered. And then this is an interactive session. So if you have any question during the conversation that we have today, please feel free to ask any question to Andrew, to CJ, and myself. We'll address that on the call, like pretty much live. I think Andrew and CJ both really welcome the live conversation. So please ask any question that you have through the chat. And so we'll get started. So before that, I would love to have our panelists to kind of introduce themselves. So Andrew, do you want to introduce yourself quickly to audience?
Sure, absolutely. I wear lots of hats, but that includes captaining most of the data-related content at Gigaom, where we cover lots and lots of things. But of course, I think data and analytics is the most important. I've been in the industry mostly focused on database and data analytics and business intelligence. It depends how you count, but since the late 80s. And I write about this for the New Stack as well. I'm involved in developer conferences as a co-chair and a zillion other things that probably aren't that important for this conversation. So I'll cut it off there.
Awesome. Thank you. CJ, you want to go next?
Sure. My name is Sijie Guo, co-founder and CEO of StreamNative. I'm also one of the co-creators of Apache Pulsar. I'm really excited to be here talking about data streaming.
All right, cool. So we'll just dive in. So main topic of this webinar is about data streaming trend. But just in time, Gigaom actually released a new radar for streaming data platform. So Andrew, just can you give us a real bit brief overview of what that is?
Yeah, absolutely. So the radar reports that we do, and I'm involved with several of them, you could kind of think, I guess, as buyer's guides for folks who are in IT procurement or making platform decisions and so forth. And they tend to focus on a specific category. So the one we're talking about today here is our radar report on streaming data platforms. This is certainly not the first edition. We've done several, and we kind of focus on a bunch of things. There's a companion report called the Key Criteria Report, where we try and be educational about the category for folks who need to come up to speed on, I don't know, either the state of the art or sometimes just describing the vocabulary is pretty important. But we group features and capabilities as follows. We have something we call table stakes, which, as the name might suggest, are kind of the minimal things that we want to see a platform have before we include it in the report. Virtually every product in this report has, or every platform has, most, if not all, of the table stakes. And we can go over what those are, but we also have what we call key features, which are really the distinguishing characteristics. Most platforms have some capability in these areas, but and we definitely will drill down on those, but different products have them to different degrees, and that's really kind of what distinguishes one platform for another. And also, if certain features are more important than others to certain buyers, then they, the decision is that much more clear. We have emerging features where we, in effect, talk about things that we think will become more mainstream in the future and are just, as the name would suggest, just emerging now, just becoming more common. So if you think about this, the emerging features today should be the key features of tomorrow, and the key features of today should be the table stakes of tomorrow if the category is evolving and moving forward. We also have business criteria, which are less about features and more about qualities. things like scalability and ease of use, that sort of thing. And again, we do these in a number of categories. We have one for data warehouses, one for data lakes and lake houses. And we've got stuff for data integration as well. It's kind of interesting how a lot of these categories are starting to overlap. And that is something that I think we might talk about more in this conversation, which is that gosh, we're starting to see streaming data platforms do some of the things that data pipeline platforms have done before, and data integration platforms as well. We're starting to see governance come in multiple categories, even though we do a separate report on data catalogs and another one on data access governance. Basically, all the different subcategories of data management are starting to play in the others territory.
Yeah, or merging, I guess.
Exactly.
Yeah. So I'm pretty sure you have analyzed, like, I don't know, multiple vendors while writing this report. So what was the kind of a TLDR for the reports? What is a kind of key trend that you see in the data streaming market in 2024?
Sure. Well, I mean, to some extent, the things that are emerging features are maybe also the emerging trends. So it won't shock you to hear that we see artificial intelligence, and especially generative artificial intelligence technology playing a bigger and bigger role, either in terms of the platform's integrating capabilities of Gen AI in the platform that help make things more usable, or to the extent that the platform can assist and support customers who are building generative AI applications. And in the case of this category, obviously want to be able to put their real-time data into the equation of making sure that whether it's predictive analytics using more mainstream machine learning, or if it's tuning and context with retrieval augmented generation on the Gen AI side, that the data in their database, or the data that's streaming in real time in this case, is something that can be factored in. So obviously it's a pretty cutting edge thing to be able to say, well, I've got this data coming in real time. Maybe it's coming in from market data, maybe it's coming in from sensors on devices or pieces of equipment that I need to monitor, and I need to know what's going on. The ability to do that, whether it's to keep a machine learning model well trained, or establish the context for RAG queries against a model, that's a big deal. And another one, if we can step away from Gen AI for a moment, I hope we can, because the industry is so obsessed with it that I feel like sometimes other things don't get the attention they should. But in general, working with streaming data is getting easier. It's also getting more important. It's getting more critical. The pressure is increasing, but also the pressure is decreasing because it's becoming more feasible for folks with mainstream database skills and mainstream developer skills to be able to work in this arena, whereas back in the old days it was highly specialized and really kind of a premium feature that a lot of organizations either didn't know how to approach, or frankly couldn't afford to include in their stable of analytics activities and practices. We can't do that anymore, right? If we're going to really have holistic analytics, we have to bring in all our data, and that very much includes real-time data. People love to talk about how data volumes are increasing, and I have this corny saying, which is, well, data is life. It's a point in time recording of something that happened to a person or an organization or a physical object. The data has always been there. The question is, how much of it do we capture, record, and analyze? Streaming data is at the forefront of that question, and it's again, it's becoming much more, within the realm of feasibility and possibility. So those are the biggest trends to me, and they manifest in things like SQL capabilities for querying the data, and more the ability to kind of, in terms of a paradigm, be able to abstract the complexities of streaming data and make it look more like conventional data that's sitting in a table in a database, right? You shouldn't have to bend over backwards and kind of flip everything around to understand how streaming data works. You should be able to kind of think of it all in the same context.
That's right. That's right. Okay.
Mhm.
Going back to CJ, do you see the similar trend from the community and the customer that you interact day to day? Yeah.
Yeah, obviously, I think there's a good point that Andrew bring up is that like from what he observed is that there's quite a lot of overlapping between data streaming and other data management systems like data warehouse. It's actually a strong signal indicating data streaming is actually became mainstream, meaning it became more like easy to use and people understand data streaming concept, and then you have these SQL capability built on top of it, so you can use it like a databases or table that people probably already familiar with using a database data warehouse. So that is a really strong signal. I think the first pattern that we have been observed from both community, industry, and our customer is data streaming has become mainstream, a mainstream thing. And secondly, I want to kind of echo on the kind of the overlapping side is the cultural speaking that we see two different sides. One is more the operational side. The other one is on the analytic side. Like in the operational side, like people typically see these transactional databases, transactional systems. And in the analytic side, there are the data warehouse, data pipelines, the data services that is running for processing the data. And we see the boundary between operational side and the analytic side became like overlapping more and more. It is the in the analytic side that you need the data coming from the business operational side, coming from your transactional database, from your messaging queue, and fit into pipeline for processing. With the rise of this machine learning and AI, you want to train the model, you want to provide a feedback to your operational side. So there's a connection between these operational side and the analytic side. And data streaming is actually playing a key important role in connecting both sides together, so you can share like using one copy of data and sharing data across different organizations and across different services. And lastly, I want to say with the kind of rise of AI, particularly in Gen AI, it's actually changed the way how you dealing with the data engineering and the model creations. And that means in order to kind of making sure the large language models to land in enterprises to be able to build Gen AI, we need the real-time data in data streams or data stream platform more than ever, because we need to continue feeding into those fresh data into large language models, make it use of the Gen AI application. And to tie all these three kind of things together, I think there's one common pattern is definitely cost. The way how I kind of think of a cost is more about a kind of economic unit, how you can best utilize the resources in the current environment and be able to run an infrastructure efficiently and use the safe capital to kind of in the business oriented operations. Like for example, if I can use a data streaming platform to fit in data much quicker in a much lower cost, I can use the save capital, probably invest in building Gen AI application to advance my business in much faster. So that's kind of the pattern that I have seen in our community, our customers who are kind of using data streaming there.
So Andrew, actually, do you see those kind of a trend from the vendor as well? Like, do you see that they've been using data streaming technology for transactional use cases and slowly like moving into the more analytic use case or vice versa.
Yeah, I mean, certain platforms even completely abstract away the differences. I mean, there's even platforms out there that make more static data just look like a special case of streaming data. And actually, if you think about change data capture, which is a technology for replicating data between databases, that really is just another flavor of streaming, perhaps at lower frequency, but it's the same paradigm. And you're starting, I mean, there used to be specialized vendors in CDC, but now what you're starting to see is that a lot of databases just support CDC replication by default. And I think you're starting to see lots of streaming data platforms being very kind of agile and saying, well, whether it's a, you know, something like a Pulsar topic or a stream from something like Kinesis on AWS, or it's a CDC feed from my OLTP database, you know, it doesn't really matter. I want to be there to be able to accommodate all of it and work with all of it and factor all of it in and be able to do my data-driven decision work based on all of it, and you know, not have special cases, not have exceptions, and not have omissions.
Right. Yeah. So actually going back to your radar, you actually picked about 5 capabilities as key feature that when you
Right.
analyze the vendors. So edge deployment, data quality, temporal feature, ML, and SQL utility. So what is the rationale for picking that 5 as key features when you analyze the vendors?
Right. So for edge deployment, you know, that's not new, but it's certainly not going away in terms of importance, especially since a lot of streaming data has overlap with the Internet of Things and sensors and devices. And there needs to be, it's kind of funny, like the more prevalent cloud computing becomes, the more acute the need to be able to do some amount of local processing that's not happening on a server. It makes a lot of sense, for example, to process granular data at the edge and then replicate the more aggregated data to the cloud or to the data center and do more, you know, global things there. So edge deployment is super important. Data quality is interesting because actually that used to be one of our topics for radar. That's kind of grown up to be more about data observability. But data quality, first of all, it's important because we're using data to support business decisions so much more prevalently, and we're also using it to build machine learning models and to fine-tune generative AI models. And if the quality of the data is bad, then the quality of the outcomes may be bad as well. But also the ability to correct and remediate data quality as it streams in, rather than bringing it in, leaving it there, and then doing a kind of retrospective inspection of data quality, is important for all the reasons we've been talking about, kind of real-time calculus being more and more critical. So for streaming platforms to be able to have at least a modicum, and hopefully more than that, of data quality features where that can at least be observed and reported on, and hopefully can even be remediated through some kind of data transformation capabilities, that's of major importance now.
Do you see that as a kind of Flink as a kind of major tool to be used for that, or?
Yeah, no, Flink is definitely important there, and has enabled a lot of scenarios. On the other hand, I kind of feel like Flink all by itself isn't enough, right? We need to be able to have abstraction layers on top of Flink. Flink is really infrastructure and plumbing, and where the value gets added is when platforms create either no code or low code interfaces around what Flink can do. And again, being able to it used to be a breakthrough that for ETL, for data integration, that we could do visual low code transformation capabilities on the data. Well, now that's really becoming critical in the streaming context as well. So that's happening. Temporal features are important really for the reasons I was discussing before, that there is the necessity to be able to even if it's a little bit of a mirage, to be able to make streaming data look like static data so that it can be analyzed in the same way. So we need the ability to put time windows on data, whether that be kind of in a fixed point of time, a sliding window, like the last half hour, the last hour, the last day, or more kind of sessionized focus on data, especially when it comes to web analytics. You want to be able to look at all the streaming data that took place in the context of some kind of session. And the ability to do that really easily is important as well. CJ, if I'm glossing over anything or oversimplifying anything, I hope you'll keep me honest here. Machine learning
You covered well.
I'm sorry?
You cover well.
Okay, good. Thank you. I wasn't fishing for a compliment there, I promise. Our other two key features were machine learning related capabilities and SQL related capabilities. So and the machine learning kind of works both ways. We want to be able to use machine learning to do things, for example, like, enforce and observe the data quality, but we also want to be able to use the streaming data to retrain models, or at least we monitor it to detect drift to see if retraining is necessary. And SQL utility, again, is all about leveraging existing skill sets, right? Virtually every technologist who's writing at least some code knows at least some SQL and is comfortable with the paradigm of SQL, of tables and rows and columns, and putting filter conditions on different columns and a where clause. That's a pretty universal shared paradigm for working with data. And it's not just data. It's not just data querying. It's also data manipulation and data definition. And to the extent that more streaming data platforms support more of those aspects, the better. It brings more practitioners into the arena, and it just makes things more usable, and importantly, also makes them usable in the same context as working with historical data. And ultimately, you want to be able to synthesize the two.
Yeah. I thought the temporal feature was kind of unique. I agree with all the other features, but like temporal as a kind of key criteria, like it's almost like you need the real time, but you also need the real time with the timestamp on it, so that you can actually go back in time and see what is happening. Do you see a lot of the use cases in, like, I know you talked about web analytics, but do you see any other use cases in other industries using that temporal features?
Oh gosh, I feel like I see infinite use cases. I agree with you. Like the whole point, it seems counterintuitive because the whole point of streaming data is that it's real time, it's point in time, and it's very granular.
Yeah.
But in actuality, if you're only looking at one row of data at a time, you're not really doing anything analytical. That's only operational. So you want to be able to look at data in groups. You want to be able to aggregate. The point is, you don't want to have to wait till the end of the day to do that. Number one, and number two, you still want to be able to be pretty precise and focused and narrow in terms of the scope of what's being aggregated. And that's why the temporal features are important. So think of finance and look at how a stock has behaved in the last, half hour. Are there signals in there that are telling you something about which way it might go? Likewise, for readings coming off of sensors, think of escalators, think of elevators, think of turbines. are you seeing patterns in somewhat in real time that are indicating an imminent breakdown? And can you then be preemptive about that to avoid a disruption? If you're only looking at, one single data reading, you're not going to be able to discern that. If
Got it.
you're looking at groups of data together, then of course you can.
I see. So like back in the days, they used to have like a batch processing with a database with a temporal feature. They did analytics, but now they're actually using the real-time and streaming data to do the same thing, but with the more recent data. I think that's actually very interesting. I think that's kind of resonate really well with what CJ talked about, how the transaction and analytical realm kind of emerge, like merging together. I think
Hmm.
which I think is a really great example.
Right.
So in that, I think CJ, you mentioned about some of the announcement that you made a couple of weeks ago that actually kind of shows that way why the transaction and analytical areas are kind of merging. And so when you actually see those kind of trends, what kind of enhancement did you make in the StreamNative platform or the personal community so that people can actually use those features more readily for both analytical and transactional use cases?
Yeah, so I think what we have been observed kind of through our customers and users is that people are not just using like data streaming platform in one side or the other side. Is actually they're actually being made as a company-wide platform that is really connecting to each other. So based on those observations, we did a kind of recent announcement in the Postal Summit 2 weeks ago. We announced an StreamNative enhanced version called Ursa Engine. It's actually an improvement that bunch of the improvement that we made over the open source Apache Pulsar. Essentially, at a very high level, it's a Kafka protocol compatible data streaming engine. So, and it's using the data, so object storage as the storage layer, and it store data into a lakehouse open standard. So meaning any data streaming into the Ursa engine can be materialized as a lakehouse table. So it would animate the needs of bespoke integrations between a data streaming system and a data lakehouse system. So you don't need to set up additional kind of toolings integrations to read the data from your data streaming platform and doing the schema mapping and converting the schema to lakehouse table. Within the Ursa engine, we just do the conversion directly. The data is storing already in object storage, and we just present it as a lakehouse table format, which using the open standard. So meaning any tools that is able to work with Delta Lake, Hoodie, Iceberg, you can continue using that tools to read the data directly. And this would also remove the needs of moving data through network. And which when you're running a data streaming platform or those integrations in cloud environments, and those cloud providers charge really expensive inter AZ traffic. So with this built-in functionality, you just eliminate the needs of doing additional transfer and really lower the total cost of ownership of running a data streaming platform. And lowering the entire TCO is actually a signal represent the like a economic unit of data streaming going into kind of mainstream, because you are able to use the real-time data in a much lower price there. So that's kind of the Ursa engine, and how does the Ursa engine fit into the chain, the patterns that we see in we just discussed before.
Got it.
I would add, and sorry if you actually, CJ, if you said this and I missed it, but your integration with Presto and Trino and therefore Starburst is also key there, right? Because in effect, that integration is making your topics look like tables in the lake, which
Yeah.
just fulfills those scenarios I was talking about before. And there, you know, you don't even necessarily have to get acquainted with even a new dialect of SQL. You're using the same tool chain and the same everything when working with your whatever flavor of Presto or Trino you're interested in, and then you're able to get to the streaming data. Basically, you know, the streaming data is coming to the practitioners instead of requiring it be the other way around. Also, I wanted to add to my own comment because it was important and I missed it. The importance of SQL isn't just about making data accessible to practitioners with SQL skills. It's also about making the data accessible to BI tools, which all continue to use SQL as their, you know, their primary their primary interface with all the data sources. There are languages like MDX and DAX that are specialized for OLAP kinds of analytics, and some tools speak those as well, the ones from Microsoft and Tableau, for example. But most BI tools use SQL. So it's not just about practitioners, it's also about business users, it's also about analysts. It's anyone who can use a BI tool, including Excel, by the way, then they're able to become part of the conversation as well.
So this is actually interesting. When I hear from CJ about streaming data landing in the lakehouse format and then it's available directly from like data lakehouse vendors to analyze those data. And then Andrew also talk about the SQL utility, temporal features. It feels like the streaming technology becoming more like a database. Do you also see those kind of trend? Is that what is the role of database and the streaming technology here?
Well, I would argue, you know, anything that could support a topic or a stream already was presenting streaming data as a database. It's just that it was a kind of a database that had a different interface and a different appearance. And as I was saying before, a kind of different paradigm for dealing with it.
Yeah.
And that's fine when something's new and breakthrough and cutting edge, and you're more focused on innovating than on putting fit and finish. But ultimately, it has to be able to come and join the same interfaces and tool chains that people are already using, so that everybody can do it and not just the kind of early adopters. And so, yeah, you're absolutely right. And I was being a little coy. Obviously, streaming data platforms are starting to make their data look like more conventional relational database tables, right?
Yeah.
Even if that's a little bit of an illusion. Illusions are okay, as long as they're well implemented. And so, yeah, that's absolutely what's happening, and it ties in with everything I was saying about the SQL utility and the BI tools, being able to touch it. The other thing that I think has started to happen, and I'm mentioning this out of selfishness really, because I'm an analyst, but I still like to be hands-on with these tools, and I still present at developer conferences and show people how to use these things. And you don't want me on your development team, that would be a mistake, but I can at least get a little bit down and dirty and show how these things work. I haven't been able to do that with streaming until recently, because how do you get a sample data stream, right? Unless you're kind of in a business where, you know, you've got data streaming in, how do you show it? And even if you do, it's probably proprietary and you can't show it. But what's also starting to happen is that there are, you know, more and more there are test streams available, or there are public data sets that are streaming, like log data from AWS, for example. So even folks who don't necessarily have a streaming use case or application yet can still build up their skills. And then it's kind of funny, once you have the skills, you see that you do have the use cases, because you know your vision for things is broader.
Exactly. We'll also talk about StreamNative Academy. So you can stream the data in under 5 minutes. Yeah, but CJ, I know that you talked about also, I think in the earlier Perseus Summit keynotes, about whether the streaming technology become database, right? Any thoughts on that?
Yeah, I think I kind of agree with what Andrew said. I mean, once you have even you don't have schema, it's sort of a certain format of databases. If you're looking into databases, there's a relation database, there's a time series databases, or sort of kind of time I would say data management system with certain format or certain schema, and being present in a way that is able to query over certain query engines using SQL standard. No matter it's a standard SQL, it's a kind of a variation of the SQL. I think it presents a way to make it easy for people to use. It's a database. So sometimes when I go into conference, people asking me what is data streaming platform, and I usually kind of use a simple terms there. It's a database of emotion data. It's just you are keeping the data, all the emotion data, including messaging, streaming, or whatever coming from different sources, and present in a way. Those are kind of structured data that is defined in certain schema. That is actually a database. And obviously there's also a category called streaming databases. Is more looking into how you converting the data streaming into materialized view, and they're doing operations there, which is kind of overlapping with some sort of the stream processing work, that you are taking one stream and doing the kind of transformation, join, aggregation, and put a result into a different stream, a different table. And essentially, I think there's a huge overlap between a data streaming platform versus streaming databases. And depending on how you view it, is actually a database of emotion data. And putting that idea out there essentially to make it the entire data streaming concept much easier to use. So it can be accepted by BI tools, it can be accepted by data scientists, and they don't need to understand the complexity of data streaming. What is the time window? Everything is being hidden in the common understanding, easy to use interface, which is SQL there.
Interesting. And then we obviously cannot leave the webcast without talking about generative AI. That's a really hot topic in the market right now. Also, in the Gigaom report, you picked that as an emerging feature. I think maybe that's an obvious thing. But how do you actually see that data streaming related to AI infrastructure?
Right. So, I touched on this before, but again, and I like to talk about AI kind of all up, including both generative and machine learning. Actually, I think one of the best things about generative AI is it's made more conventional ML more widely adopted, even if that's not what people are talking about on the surface. But yeah, the ability to involve data as it streams in queries, or or being able to vectorize it almost on the fly, and then being able to use the vectorized versions of the data as contextual data in a RAG, a retrievable augmented generation type of query. Those are, all those things are becoming critical. They're becoming critical for a couple of reasons. This is always the thing in tech, right? There's the stuff that people are doing and the stuff that people are talking about doing, right? And the stuff that the practitioners are talking about, and the stuff that maybe executives who are reading about these things kind of second source are concerned with in terms of staying competitive and so forth. But what's really interesting about generative AI is it's up and down that whole spectrum, right? So whether you're a Python coder or a Java coder or a C# coder, you know about this, right? And so do your parents. so does your CEO. It's generative AI is kind of figuring into everyone's consciousness. So for the technologist, it needs to be actionable. And certainly there, even for folks who aren't hands-on with the tech, right, they have concerns that it be included. The fact that ChatGPT is in effect an end user tool, and about as friendly as the search engine, has kind of made it so that even non-technical people, sometimes more so than the technical people, are very savvy about what generative AI can do. So yes, we have as our two emerging features, we have generative AI capabilities, and those work both ways in terms of being used in the platform to enable natural language features on top of the more complicated things the platform can do. And then again, also being able to supplement and augment and facilitate generative AI applications to use the streaming data within them. And that can be broadly speaking, or that can be specific to vector capabilities. We're seeing in relational databases, more and more of them are getting vector search and vectorization capabilities, instead of having to go out and use a specialized database to do that. And we're starting to, by that same principle, we're starting to see more and more streaming platforms be able to do the vector operations right in place without having to go out to some secondary platform to get them done.
Sijie, any thoughts about generative AI also?
Yeah, I think I kind of agree with a lot of what Andrew just said, and I think I was actually in a Gen AI summit this week, and one of the observation and kind of a common alignment that I've heard people talking about is large language model is great, but if you want to put large language model into enterprises and landing the large language model in enterprises for building enterprise-specific Gen AI applications, you need large language model is actually trained based on the public available data. They don't have any access to enterprise domain-specific data. So meaning, if you want to let the large language model be useful in enterprises, you need to have the capability to feed in domain-specific data into a large language model to be able to augment that large language model to generate the right responses. And that's where data streaming platform coming into a play, that it offers the streaming capability to collecting all the data from different data sources and feed the data as continuous data streams into large language model through that entire RAG framework, and be able to serve those embeddings ingest the embeddings into vector databases and update it and be able to kind of serve the queries there. So that from that perspective, I think data streaming platform is going to be a foundational component to making Gen AI application useful in the enterprise context.
I see. It was actually going back to what Andrew mentioned in the beginning, where data streaming become like a de facto standard infrastructure for many industries now. Okay, it's happening in the generative AI as well. That's very exciting to see.
And with small language models, that's also becoming relevant on edge devices, which then reinforces the importance of edge capabilities in streaming platforms.
All right.
All these things overlap, right? There's it's almost like time windows with streaming data, right? We bucket them somewhat arbitrarily so that we can look at them in isolation and understand them, but really those delineations can be a little bit artificial.
Yeah, very cool. Yeah, thank you so much for the very insightful discussion. So we'll move to Q&A. So if you have any questions, please use the Q&A chat button below, and we will read out the questions from there. But I have one question here. So first question is, StreamNative is named as a leader in the Gigaom report.
Right.
The strong platform capabilities, along with the Confluent, Hazelcast, and Stream. Can you share some common characteristics and capabilities of these vendors?
Sure. So all four of you are, unfortunately, we don't have the visual, but all four of you are kind of in the lower right-hand quadrant, which means on the x-axis, we talk about platform plays versus feature plays, and you're in the former, so you're on the right. And then on the vertical axis, we talk about innovative versus more stable. And you're on the bottom there, which means you're on the innovative side. So you're innovative in platform. Platform because streaming is really everything you do. So it's not that you merely have a couple of streaming data capabilities within a broader data platform, and there's nothing wrong with that. But your scope, your focus is on streaming, and then all the capabilities are within that scope. So that's what puts you on the right, and what puts you in the lower half, which is in our case the better half. There are a lot of analyst firms out there that your goal is to be as far to the top right as you can. For us, it may often be the bottom right, but you're innovating very rapidly, and that's why we have you there. And if your nearest peers are kind of in the same place. So whether it's Stream, Confluent, or Hazelcast, you're all innovating and excelling on our key features. You're all focused on streaming data rather exclusively, and StreamNative is really the key corporate entity behind the open source Pulsar. Obviously, Sijie, very instrumental in both. And your pure Confluent is in a similar position with, for example, with Kafka. So that's why you're kind of peas in a pod there, but that doesn't mean you're all the same, certainly. It just means you kind of have a similar approach and focus.
Got it. Cool. All right. Next question we have is the data streaming is getting more and more common, as you both talked about it, but I'm also getting a lot of pressure from management to reduce the cost for data streaming. So what can I do? Yeah.
Is that for me or for CJ?
I think you can both answer the question. What is the best way to save the cost for the data streaming technologies? Yeah.
I can go first since Andrew just answered one. So the way how I view this is when you saying cost reduction or cutting costs is we need to take a look into what is the business requirement, and are you looking into latency sensitive? Are you be able to relax latency, which you kind of to a certain extent they kind of represent two different type of workloads. And also we need to take into consideration what are the constraints, because we are living in a much complicated world comparing to a couple of years ago. It's not pure cloud-based. It's not pure on-premise. It's actually a mixed hybrid environment. Some of the environment running in cloud, some of the environment running in like on-premise private cloud environment. And when you're running on cloud, people, some cloud provider charge inter-AG traffic. Some some cloud providers don't charge that, and in the on-premise environment, you don't have that inter-AG kind of consent. So when taking those constraints into consideration, and in order to meet the business requirements, you cannot develop one solution to just fit in all. You actually need to give people options. So like that's kind of a principle that we use for developing our ERSA engine and our product. See sensitive workloads, then we are able to give you latency sensitive workloads type of profile, and making sure when you running this setup is actually effective. And similarly, if you're looking into streaming, which we can probably using object storage as a storage layer and be able to kind of store data in object storage directly. So in that way, you can remove the needs of inter-AG data replication. which can save tons of the money if you're running on public cloud. So that's kind of the approach we're taking there, is to offer a data streaming platform with flexibility and options to meet your business requirements and taking your constraints of your deployment environment into consideration.
Yeah, absolutely. I
So
mean,
that's more kind of from technology and a product perspective. Yeah.
yeah, I mean, network cost is really, really high for the data streaming. So managing that based on your priority, I think that's really important. Andrew, any thoughts you'd like to add?
Yeah, I just
Yeah.
remember what CJ was talking about earlier about the open table formats that are becoming more standardized. And, you know, if you can drop everything in Delta Lake or an Iceberg in object storage, that's an automatic savings because there's so many other engines now that can query that data directly. And you don't, I mean, the data is instantly available, it's instantly usable. That then powers business decisions that are more informed, and you're also, you know, you're also saving at least something on storage costs because you don't need copies of your data. But also all the ease of use stuff that I was discussing before, you know, it isn't just about it's easier and more enjoyable and therefore less intimidating. I mean, ease of use is productivity, which is cost savings, right? Because you're saving on training, you're saving on recruitment, and you know, what it takes to have the skill sets in house, and all that stuff is super important. The ability to integrate with your existing platforms and your existing people and their existing skill sets is a huge time saver. It just may be that the costs that it's saving on are otherwise hidden, but they're no less significant for being hidden.
Yeah, for sure. I mean, if it used to take like 10 hours and now it takes 1 hour to do that, the time saved, that cost and infrastructure from like full-time employee cost perspective is huge saving, right? Yeah.
It's part of the total cost of ownership, the TCO, and often overlooked as such,
Yes.
frankly.
Good. All right. I think that's the older questions that we have. So thank you so much for answering question, and thanks you for the audience for being very active audience. I would like to again thank you for Andrea and CJ for kind of sharing really valuable insights to us. Cool. So we will come back again with the next webinar. But thank you everyone for joining
Thank
webinar.
you. Thanks for having me.
Thank you. Thank
All
you.
right.
Bye-bye.
Take care.